Hello, everyone. Today's lecture is about sensor fusion and AI in autonomous vehicles as part of the workforce development for autonomous transportation series. So the goal of this lecture is to understand how the autonomous vehicle see the world. So there are some certain objectives like you can describe the sensors, perception systems like explain that no single sensing modality is sufficient in real world driving um, applications. So then you can describe the concept of sensor fusion for perception in AVs and understand some concept of AI and different kind of the neural network. I'm going to briefly talk about that and show that how the sensor fusion is required to improve the safety on some challenging condition in AVs. So now we talked about the sensor technology in the previous lecture, and I want to go quickly over what we had because the sensor fusion is completely connected to that concept. And when we talk about the sensor, it's about a device that detects, measures, and responds to the environment, all right? Like which can be physical, chemical, and even it responds to environmental changes such as light, heat, motion, pressure, temperature, okay? And it converts those physical phenomena into some signals which can be used by the computer or controller, which technically those signals they are electrical signals as long some voltage or current. As examples of the sensors are like camera, radar, LiDAR. We talked about them and in the sensor technology in the previous lecture, or IMU, right? So sensors in an AV or many other applications like robotics application industries, they act like eyes and ears, and they bridge the gap between the physical environment and digital world, like the way that the world can be seen. So by some technology, all right, this is what it is captured by sensors. So now in autonomous transportation, the vehicle must perceive the environment, understand road users and infrastructure, and make safe decisions. And everything should happen in real time. Okay. So when we talk about the real time, it's about the making decision like as a human. When you are driving and something happens, you just make a decision and make a safe decision and then react to that change in environment. So it can be either like brake or even like make like push the gas pedal and increase the speed. So it's not something that like vehicle can take information, work on them, and then react. So that is what we call it offline. So it doesn't work in an offline manner. So like human, when we are doing any kind of the daily activity, we rely more on vision and hearing, like through our eyes and ears. And any kind of the autonomous application, autonomous robots, or autonomous in this specific case that we are talking about autonomous vehicles, they rely on sensors that they work together. So now we have, that in the sensor technologies lecture, we talked about different kind of the sensors that we have. So we have some exteroceptive sensors that they capture the environment like camera, LiDAR, radar, ultrasonic. Then we have some proprioceptive sensors that they give information about vehicle state like IMU, wheel encoders, odometry, and then we have some positioning sensor that they are GPS and GNSS, like gives information about the positions of the car. Now, the perception system in an AV, which autonomous vehicle needs that uh, because it senses the environment, it interprets the traffic participants, and it builds a consistent word representation, right? So these are all actions that they are required and they have been done by perception system through the sensors. And that is the first and most safety critical stage in the AV pipeline. Like because if any part of these three steps is missed, then we cannot actually expect a safe decision making of AV. And how does a perception system work? And what is the definition of a perception system? It is a system that processes multimodal sensor data to achieve accurate, robust, and real-time understanding of the driving environment. And key characteristics of perception system is to understand, is to combine, and interpret. Now, in especially for autonomous vehicles, especially for driverless cars, the perception system has to be accurate. This means that they need to give precise information of driving environment. They have to be robust because they should work properly in adverse weather, like if it is rainy, if it is like some foggy or like snowy, they should work. This is what we talk about the robust. Um, and they are real time. They should perception systems should work as a real time because um, like especially when the car is working with the highest speed. Okay, that's so important. And and these are where when we talk about the multimodal sensor, it actually it's about the having multiple sensors, they're working together, okay, and to create an accurate perception system. Now, why do we need multimodal perception for a system? Because as we talked about it, that in the sensor technology, no single sensor can satisfy all the perception requirements, right? Like we cannot just rely on cameras for the perception because the lighting conditions, the weather condition, quality of camera, it affects the perception. And sensors, they have some complementary properties. Like, for example, cameras give semantics, information about the system, about the environment. LiDAR uh, give uh, gives the geometry, some information about the geometry. And radar is more in motion and helps in robustness because it has less effect in the worse environment. Um, so so sensor fusion is fundamental, which and it is not an optional. Now, what is the sensor fusion? Sensor fusion is the process of combining data from multiple sensors to form more accurate and reliable understanding of the environment. So instead of relying only on one sensor, so we use multiple sensors. We use the information from multiple sensors, and then that information will help us to understand the environment. So and the main goal of sensor fusion is to help sensors to cover each other's weaknesses. So rule of sensor fusion in perception. So sensor fusion combines heterogeneous sensor data. When we talk about the heterogeneous sensor data, this means that we can, uh, heterogeneous term means that we have sensors from uh, like different types of the sensors. Like we talked about the camera. Camera use light. Like radar sense like radio wave signal. laser LiDAR uses laser, right? In order to get, and each sensor gives some certain information. Okay, so that is what we have: heterogeneous sensor data, and sensor fusion combines that, and it increases the clarity of the data, and it improves reliability under sensor degradation. So if like some sensors they don't work properly in certain condition, then they will cover the data that we receive from different sensors. They will cover uh, themselves. So and fusion supports in an AV and in a perception system supports object detection, semantic segmentation, and localization. It helps in these three main areas, which is critical in AVs. So, and here you can see an image of how different kind of the sensor, like radar, the radar can detect the speed and objects, like LiDAR gives some information about the environment, and camera gives a semantic, and how these three information they can be used and fused together and help with the perception system in an AV. So, and the tasks of the sensor fusion in autonomous driving, it's for object detection and tracking, lane recognition, localization and mapping, and collision avoidance and emergency braking. So these are like some main tasks. Like there are so many other like tasks that sensor fusion can help with that, but these are the main ones that we have. So there are some certain algorithms in sensor fusion, and which here we have just I listed some part of that, which we have as a it is called the Kalman filter, and this is common in linear systems and used in vehicle um, motion model. So you can see over here that so sensor data processing, it gets information from radar, camera image, LiDAR, and then like some certain algorithms, they will work together like radar object, image object, and 2D point map. This is the output of LiDAR data that we get after some processing on that data. It comes to the sensor fusion, and then it will give some estimation of the objects, all right? So that what is that object, and how far is it, and what is the speed? So this is where we can uh, have some object fusion and state estimation of the AV. And there are so many extensions of on this algorithm, like it is called extended Kalman filter. It works on nonlinear systems. In control, we have linear and nonlinear systems, and even extended Kalman filter used in vehicle localization and pose estimation, right? So these are just some popular algorithms in sensor fusion. So so here this is another example of how different information from camera and LiDAR they are they are used in the self-driving, all right, to give some semantic information in the upper part of the images. You see the camera information, and down is where the information which is given through the LiDAR, like giving some mapping or localizations, that because the the image on top, it's just a 2D image of the vehicles, but in down you can see some other information about how far it is and a distance, like some mapping of the environment. And that is what these two information they help each other. So and again, in terms of applications, we have perception and object detection, which uses the camera, LiDAR, and radar. And fusion will help for 3D mapping, object detection, and classification. So it also helps in lane detection lane detection uses a camera, IMU, and GPS, and it's that fusion used to keep AV in lane and in proper lane changing, right? That helps with that, and it improves the redundancy from simple camera algorithm. Now, sensor fusion improves the performance in the like some environment, like in the worst weather that we have, or other issues in the environment, like poor lighting, right? So night, glare, shadows, that camera, they don't work, right? Cameras like 2D camera don't work. Then we need to use some thermal camera or use um, like radar and other sensors. Or in adverse weather, like rain, fog, snow. So this is what we have, like that affects certain sensors, but other complementary sensors like radar and lidar, they can help with some part of that. And um, and it also, sensor fusion improves the partial sensor failure, right? If for any reason one of these sensors that they are installed on the AV, it doesn't work, or for some reason doesn't, like the sensor has some hardware issue or anything, because these are all mechanical and electrical devices, and they may not work like regular appliance that we have, and sometimes they work and sometimes they not. So this and if some of these sensors they got failure, then other sensor they will work, they will help to covering um, the perception system. Because again, the autonomous vehicle is a system that needs to react in real time, all right? It cannot, it doesn't work. So we cannot, if some sensor has some issues, we cannot say that the car should stop until they, like, some technician come and fix it, and then get back to work, because it might be in the middle of the street, it might be in a certain emergency mission. So we have to be careful about that. And again, sensors in the sensor fusion, they back each other when one of them becomes unreliable. Uh, and that reduces the single point failures. And this will increase the system robustness, reliability, and trustworthiness. So this is how the sensor fusion is so important. And recently, so many algorithms in the artificial intelligence, like, also help in the perception system and sensor fusion. Now, when we talk about the AI, especially in the application, with the applications in the autonomous vehicle, so first we need to know what is artificial intelligence, all right? What is AI, and why do we call it AI? And you may have heard this term a lot recently, and many, like, for the large language models, which is called like LLM, you may have worked with the ChatGPT as some example of AI. So you know that human, human has some intelligence to um, do some certain tasks. Like whenever a problem is given to you, so then you will think about it, you will learn how to solve it, and you will solve it, all right? So now, when we talk about AI is a system that is going to perform some tasks that they are similar to human-like intelligence. So then they can do some perception, they can do some sort of the processing and analysis on those tasks, and then make some decisions. Now, in AVs, autonomous vehicles, AI is used a lot in seeing the environment, in recognizing, and in interpreting the environment, right? So, and that's critical, okay? And you need to think about it. So AI is a software that learns from the experience that it gets from the environment, right? So pretty similar to the human. Okay, we have some interaction with the environment, and then we learn from the environment, right? So like you take the course, and then you um, do some certain homework, and you learn some topic. Then at the end of the semester, when you see some question regarding to that, or even when you go to your career in some industries and you have something similar to that topic, you learn that environment, learn that topic, and you will use that experience to solve the problem. Okay. So this is exactly what an AI should do. So now in AVs, there are so many terms and concepts, and which AI is referred to, but recently it's talk about some data-driven algorithms. So when we talk about data-driven algorithms, this means that we have some like software or some coding or some algorithm that they work with data. So the input to those algorithms, it's some data from the environment, which for the case of AV is data coming from the sensors, right? And then based on that data gives like some certain information, and it contains like very important um, pattern or very important information about the environment. And that algorithm, AI algorithm, should detect that, right? So, and this is what it is, a data-driven algorithm that learns the patterns that they exist in the data. Like, for example, as a simple example, consider that there's an image, and in that image there are multiple objects, and and then the algorithm, AI algorithm, should detect what is in those images. So if it is like the objects that they are in the image, if they are like some car, bike, human, like animal or anything, right? It's a building or anything, right? So, and this is a pattern of the data, and it will learn about that. So in the perception state, the data comes from the store, right? From the sensors, which use to understand the environment, right? In the prediction, it is the predicting change of the other vehicles, obstacle and pedestrians, all right? So this is how AI works on that. And it also assists in decision making, like road management strategies, like based on the data and the pattern that it learns, so it can predict that right now it needs to turn or yield or overtaking. Now, you may also have heard about machine learning, all right? So artificial intelligence, machine learning, and machine learning is also a subset of artificial intelligence, right? And machine learning is where the so all these categories, it's like AI is an umbrella, and all other terms they are under the AI. So it's a system that they learn pattern from data instead of like using fixed rules. All right. So now, if you take a look at here, so you can see that machine learning is some tools that they learn pattern from data, right? Now, in order for that learning environment or that learning procedure to be accurate, right? We need to have some more data or accurate data, or we talk about it like some good quality data, right? So good quality data will improve the performance of machine learning, right? So you would learn better, right? And that's critical in all these algorithms. Like, even that happens in the regular life as well. Like if for any certain topic or object, if you have enough resources to read, then you can have a better understanding of that topic. And if something happens or like some issues, or there are some questions or problems for you to solve and you have enough resources, then it's more likely that you can solve that problem. But if there is some issues or some problems that you don't have enough knowledge about it, or you don't have enough data to explore or enough resources about it, so that will make the procedure of finding the solution to that process like longer. And it's the same thing that happens for that machine or that tool, right? In the machine learning. So example of machine learning in AVs are that to show like how many labeled images of car, pedestrian, and lanes. Um, so the model learns to recognize them automatically in new situations, right? So if you there are some data, and you train we this is what we call it, training. You train the model with that data, that okay, if you have this image is a car, this image is a pedestrian, and this image is a lane. So when you train that model with that certain information, right, so it will learn that the pattern of that data. And now when the situation changes, because this autonomous vehicle, they work on different environment, all right? It will recognize those objects in the new environment, right? Or in new situations. It doesn't have to be in the same environment, all right? So because it's already learned that pattern, and based on that, it can make a decision that what the object in that certain environment is. Now, the core of all these approaches, like AI and machine learning, is a neural network, all right? And what is a neural network? Neural network is inspired by how the human brain processes the information and how the human brain works, because there are billions of neurons in the human brain that they work together, and and it's the most sophisticated, we call in the control engineering side like the controller in the world, right? So and neural network is made of layers of simple processing units, which they are called neurons, right? And you can see over here in the figure in the left, it's a single neuron. It's a general single neuron, which is modeled as some input with some like mathematical equation. F is what we call it as some activation function, and we have like different kind of the activation function. We have different kind of the neural networks, which I don't want to go through the details over here. But this is how a single neuron looks like. Now, Then the way that the human brain works is that there are billions of neurons, they are connected, and and then there are different kind of the layers of the neuron. And what happens is that each layer, so layer is what we call it, the combination of multiple neurons, they make a layer, right? Like for example, you connect 10 neurons because you have like 10 inputs for a certain problem. Then this is going to be the first layer or input layer. And all these neurons, they are connected together to different layers and eventually create some output, which you can see over here. And you can see that how this output mathematically, I have a equation over here, how mathematically all these like layers, the output of one layer is the input to other layer, and the overall structure is the same. And again, so this is a hierarchy that we reach to the end or output layer in neural network. And each layer extracts some feature of data, right? So this is how it works, and you will see that how do we work on that. Now, this is a simple explanation of the neural network. Now, there's a concept of deep neural network. So the reason which I'm talking about this because these are something that you may see a lot. You may see those concepts in AVs or heard about them. And I just want you to have some basic knowledge about what is a deep neural network, what is a neural network, and what is some other like convolutional neural networks too. So now, when we talk about deep neural network, it's a neural network that when when we have a neural network, we have some input layer and we have some layers like first and second layer, they're called hidden layer, and we have some output layer, right? So a deep neural network is a neural network with many hidden layer that it can learn the complex and some certain patterns from large data sets, right? So, and when you have a very large data set, like especially for the AVs that we have like tons of data about the cars, about pedestrians, about different objects. So in order to learn that kind of the pattern, so we need to have deep neural network, or it is called a DNN. And so it can model nonlinear real world relationships, scale, and it can scale effectively with the large sensor data sets. It can work with those kind of the environment. So, and in AV applications, so deep neural network is used for accurate object detection, lane recognition, traffic sign recognition, and uh, and it actually forms a backbone of some modern perception systems, right? Which again, recently there are so many developments of that. So this is how a deep neural network looks like. So you can see that there is an input layer. It's a dimension of data that you apply to the system. And then there are so many hidden layers. All the layers all the way from here to here, they are hidden layer. And then the system generates some output. Okay. So, and that is what the hidden layer, the input layer is the data that we capture. These hidden layers, they will extract the patterns of that they are stored in the data, all right? Patterns that they exist in the data, and then they will generate the output. Now, another type of the neural network that we have, again, we have that concept in the AVs is convolutional neural network, right? And it's a specialized neural network which has application more in images and spatial data. Now, what is the main benefit of the convolutional neural network? It actually automatically learns visual features through layers. Like, and whenever there is an object, it takes edges, shapes, and in each layer extracts that information and then detects what the object is. And it's like convolutional neural network widely used in AVs in object detection to detect like pedestrians, to recognize other vehicles, to identify road features like lane detection, traffic sign recognition. And it reduces the need for manual feature design, right? Because it's not easy to um, include all the features that like different cities and all the traffic sign recognitions and different situations of the road to put that manually in the perception system. And it enables the robust performance. And the information that is used by convolutional neural network is the camera data, right? It works with it uses the images to interpret the environment and then find the objects. So this is an example of a convolutional neural network. So there is an input and it has different kind of the approaches that it's like pulling and it maps the features and it has some sort of the classification approach. It has a feature extraction process. It has classification, and it will give some probability of, like, for example, the input is for what percentage it is a horse, for what percentage it is a zebra, and for what percentage it is a dog. Okay, so which is like in this case, it's 20%, about 70%, it actually detects the input as a zebra, and then 10% it detects it like as a dog, all right? And definitely, and in the output, so you can pick uh, the one that has the most actually probability distribution. So now, sensor fusion and convolutional neural network is where the cameras, the data goes to the CNN and convolutional neural network extracts rich visual and semantic features of the environment. And now LiDAR provides accurate 3D geometry and depth structure. Radar measures motion, relative speed, robust in bad weather. This is how like all this information comes in the sensor fusion. And AI learns how to fuse complementary information from all sensors, all right? And this will result in what we call it a unified and robust understanding of the environment and is called a multimodal perception, which is the perception that comes from uh, different types of the sensors and comes from the data that is gathered from the environment in a real time, but in from and they are completely different, and all these information goes to the sensor fusion and AI tools. Now, here is an example of like the work that has been done, like a complex urban scenario for autonomous driving. You can see that this figure has some RGB image. It's a combination of some RGB image, some LiDAR point, some radar points, and you can see how this object detection network it works. That it detects there is 99% this object. You can see the square around the vehicle. It's a 99% accuracy that this is a vehicle. So this is, you can see that all the red parts, they are like the objects with different accuracy, like 96%. And you can see that even the radar points and mapping, that how this information they are connected together. And and this is the object classification approach, all right? Object detection and classification. Like persons, so this is 98%, this is 80%, and you can see that it depends on the the image in real time, okay? Because the system is taking images through the cameras, and that image will feed to the convolutional neural network, and that CNN is already trained, okay? And this will detect, like for example, when you have an accurate image that you can see the human is being seen in that, so then the probability of detecting that as an object is 99%. Or even the road sign, you can see right here, this is a road sign that it detects. So all these features with the like some bluish square, um, they are like 94% of road sign, and others they how it got detected. And there are some traffic lights as well, right? So which is detected and by again information that comes from different sensors and goes to the like especially the ones from the RGB from the camera goes to convolutional neural network and will detect that. So and this is also another multi-view 3D object detection network. These are just some examples that uh, I found in like some references, some papers that um, so the information about the LiDAR, information about the like bird view, front view, and image, they come through some convolutional layers, and and then this is a work that is proposed by reference one, and then they will detect the like the environment, all right? So in terms of the object detection and how different kind of the layers of neural network, they work together, they are connected, and that information comes to some fusion network here. So you can see that sensor information from different sensor sources, that data comes to the fusion network and then helps in multi-class classifier or 3D box regressor. And you can see that, so this box is, this gives information about the environment, right? So now the challenges in um, sensor fusion, which is important, is the first one is high data volume. Okay. Um, Now we have so many sensors in an AV, and all those sensors in real time, they generate large amounts of data, that those data must be processed in real time. Okay. So this is the first one that we need to have those kind of the hardware to store those data and to process them in real time. Then once that processing comes into play, then it requires a computational demand, right? So sensor fusion and AI algorithms like CNN, deep neural network, and that sensor fusion, they require significant onboard computing power, because like especially for higher speed, all those detections, object detection, and everything that has to be done in a very short period of time. Okay, it cannot take a long time, because that's information from perception system that will go to the control system that we're going to talk about in the next lecture and affects the performance, affects the safety, affects the reliability of an AV. So then the sensor fusion are all in AI algorithms. We talked about it. They are based on the data, right? Which the data that comes from the sensors. Now, the sensor calibration and alignment is so important because if the data which is coming through those sensor fusion, they are not accurate, so then the system will not be reliable, right? So that is what we need to have an accurate temporal alignment between sensors in order to have a reliable fusion. And still, like AI explainability part of it, like understanding, interpreting AI-based fusion decisions, still it's a little bit, it remains difficult. Now, sensor fusion connection to civil engineering, and it's important. We need to know how these different areas that are connected together. So something which is important is that that the sensors that they are installed on the vehicle, those sensors, they capture objects in the environment. Like they read those objects, they see those objects, and they give information from the environment. So it's important that infrastructure of the transportation, it has clear markings, some consistent signage, and some predictable layouts, right? Which will help the sensors to see the environment much better. Because a poor infrastructure will create poor perception and it will affect safety and reliability of the AV. And that is how civil engineering design in that kind of the environment in infrastructure directly affects the AV perception quality. Now, a very good quality infrastructure, a very well designed and good quality infrastructure will create a very strong perception, right? More accurate perception. And a poor infrastructure will affect the perception and eventually affect the performance of AV, right? So this is all for this lecture, and these are the references for the sensor fusion. If you are interested, you can take a look at that. So in the next lecture, we're going to talk about the control system. So, and this is how the topics are connected. So we had the signal system, we had the sensor technologies. Now we have sensor fusion, how to connect this kind of the sensor information together and create the perception system. Then we're going to have the control system, and eventually the last lecture is going to be about the communication systems in an AV.